Okay, for section C, and this section consists of 6 questions of 3 marks each, and we are going to solve both the parts. So that is for start with part A, and it's given that we have to find the ratio in which the point 8 comma 5 divide the line segment between the points 1 comma 2 and 2 comma 3. So let this be point P, 8 comma 5 y. It divides line segment joining the points, and these points be A 1 comma 2 and B 2 comma 3. So we have this line that has the points A. So this is, let's say, point A, this is point B, and this is point P. So coordinates of A are 1 comma 2, B are 2 comma 3, and P are 8 comma 5 by 1. And let P divides it in the ratio case to 1. So this is P, this is A, and this is B. So let P divides AB in the ratio case to 1. So we are going to use the section formula, and let's put in the respective values. So using section formula, which gives us the coordinates of the point that divides the line segment in the ratio case to 1. So this is equal to m1 x2 plus m2 x1 upon m1 plus m2 and m1 y2 plus m2 y1 upon m1 plus m2. Now, this is m1, which is k, m2 is 1, and these are x1, y1, and these are x2, y2. So let's put in the value. So x comma y is given to us, which is 8 by 5 comma y, and m1 is k, x2 is 2, m2 is 1, x1 is 1, m1 plus m2 is k plus 1. Now m1 is k, y2 is 3, m2 is 1, y1 is 2 upon k plus 1. And if we simplify this, so finally we have 8 comma 5 upon 8 upon 5 comma y is equal to 2k plus 1 upon k plus 1. This is 3k plus 2 upon k plus 1. And let's equate these, the corresponding coordinates. So 8 comma 5 is equal to 2k plus 1 upon k plus 1. If we cross multiply this, this is 8k plus 8 is equal to 10k plus 5. So this is minus 2k is equal to minus 3, and the required ratio is 3:2. So it's asked in the question, we have to find the ratio. To the required ratio is 3:2. So required ratio is 3:2. Now we have to find the value of y. We can write here required ratio is 3:2. Now if we have to find the value of y, let's equate the y coordinates. So y is equal to 3k plus 2 upon k plus 1, and y is equal to 3 into k is 3 by 2 plus 2 upon 3 by 2 plus 1. So y is equal to 9 by 2 plus 2 upon 3 by 2 plus 1 is 5 by 2, and this is equal to 9 plus 4 is 13. So this gets cancelled, and y is equal to 13 by 5. So the value of y is 13 by 5. So we have solved part A, and now let's move on to part B. So I'm going to erase this. So, okay, moving on to part B, we have to show that for the given coordinates of a quadrilateral or a rectangle. So ABCD is a rectangle that's given to us. So this is part B. And let's draw our rectangle. So let's say A, B, C, D. This is the rectangle with the given coordinates, and P, Q, R, S are the midpoints of side A, B, B, C, C, D, and D. We have to show the diagonals of the quadrilateral. So let's join the midpoints. So I'm going to join the midpoints and I'm going to label them. So this is A, coordinate A, B, C, and D taken in order. So coordinates of A are -1, comma -1. Coordinates of B are -1, comma 6. And coordinates of C are 3, comma 6. Coordinates of D are 3, comma -1. And P is the midpoint of AB, Q is the midpoint of BC, R is the midpoint of CD, and S is the midpoint of D. We have to show that the diagonals of the quadrilateral PQRS bisect each other. So these are the diagonals PQRS. Okay, now let's find out the coordinates. First of all, let's find out the coordinates of P, Q, R, and S because these are the midpoints. So we are going to use the midpoint formula, that is x1 upon x2. So I'm going to find the coordinates of P. So coordinates of P are x1 plus x2. So -1 plus -1 is -2 by 2, and -1 plus 6 is 5 by 2. So the coordinates are -1, comma 5, comma 2. And I'm going to use this for I'm using this formula x1 upon x2 by 2 plus y1 upon y1 y2 by 2 for the midpoint. Similarly, then let's find out the coordinates of Q. So coordinates of Q will be -1 plus 3 by 2. So coordinates of Q is -1 plus 3 is 2. So this is 2 by 2. And 6 plus 6 is 12. So 12 by 2, which gives us 1, comma 6. So the coordinates of Q are 1, comma 6. And let's find out the coordinates of point R. So coordinates of R. So, and we are using this formula to find out the coordinates of these midpoints P, Q, R, and S. So for R is 3 plus 3 is 6, but divided by 2 is 3. And 6 minus 1 is 5. So this is 3, comma 5 by 2. So 3, comma 5 by 2 and coordinates of point S. So coordinates of point S is -1 plus 3 is 2, comma 2, and -1 is -2 divided by 2, which gives us 1, comma -1. So we have the coordinates of the midpoint, and now we are going to find the coordinates of the midpoint of R, because if the diagonals bisect each other, so the midpoint of R for PR should coincide with the midpoint of QS. So let's find out the coordinates of PR and QS. And if the coordinates are same, that means that these diagonals bisect each other at O. So coordinates of midpoint of both the diagonals and coordinates of midpoint of first diagonal is PR and the second diagonal is PR and QS. And we know how to find the coordinates of midpoints. So PR, so P and R. So -1 plus 3 is 2 divided by 2. 5 by 2 plus 5 by 2 is 10 by 2, which is 5. So the coordinates are 1, comma 5. 1, comma, sorry, 5 by 2. 5 by 2 plus 5 by 2 is 10 by 2. Okay, so the coordinates are 1 comma coordinates of midpoint of diagonal PR. So this is 5 by 2 plus 5 by 2 divided by 2. These are, so minus 1 plus 3 is 2. So 2 divided by 2 is 1. And 5 by 2 plus 5 by 2 is 5 divided by 2. So 1 comma 5 by 2. And the coordinates of midpoint of QS. Coordinates of Q is this and S is this. So 1 plus 1 is 2 divided by 2 is 1. 6 minus 1 is 5. Okay, finally, the coordinates of midpoint of PR is equal to coordinates of midpoint of QS. So therefore, that means the diagonals bisect each other because their midpoint is same. So we can write here that since midpoint of PR is equal to, or these are the coordinates. Coordinates of midpoint of PR is equal to coordinates of midpoint of QS. So that means diagonals PR and QS bisect each other, and if they bisect each other, that means that PQRS is parallel. Okay, so we are done with question number 26. Let's move on to question number 27. Thank you for watching.